Hi, my name is Lenin Harkoven. This is my lab 2, motion of a falling object. In this case, we have a non-zero net force. And the Newton's second law looks like this. We observe that final velocity is different than the initial velocity. In first model, net force is just due to the Earth's gravitational pull called the weight. In second model, net force has two terms, the weight and drag force. Drag force magnitude is proportional to the square of the object speed. This force has the direction of the velocity. I drop a ball downwards. The radius of the ball is 0.063 meters. I consider it about 20 frames. The axis is in the middle of the ball. The motion starts at origin. The time is about 0.666 seconds long. And the final position is minus 2.031 meters in negative y direction. In first model, we put some information in phi2, radius of the ball, the mass of the ball in kilograms, the initial position, the initial velocity, the time start at 0, the time step, the constant g, j hat vector, and the proportionality constant b equal to 0. This model doesn't consider the drag force, therefore b equals 0. Then the net force is just equal to the weight. We observe the results. This is the final position. Second model considers the drag force. Therefore, we must find the constant b. In this case, equals 0.00233. Here we can see the drag force vector. The component y equals b times the square of the final speed. We observe the graph. The red vector is drag force and the yellow vector is the weight. And we can observe the new final position. In this graph, we observe the experiment versus no drag model and drag model. No drag model has a different last positions. The drag force model is almost equal to the experimental curve. We conclude that the model works well. Note that for intermediate times, there is a little difference between the two graphs. Which models predict the terminal velocity? Terminal velocity is the velocity when the net force is equal to 0. This will cause that the velocity stops changing. We observe the velocity changes in time. In both cases, it is still increasing. Perhaps in the drag force model, if the fall distance will be greater, the terminal velocity will be reached. So the answer is none, because the velocity continues to increase until the end of time, 0.666 seconds in both models. What if the object were thrown downwards with non-zero initial velocity? This is the new initial velocity. We obtain these graphs. The slope in the second one is the same, and the drag force vector is approximately equal to the weight vector. So in this case, the terminal velocity can be reached more quickly. Thank you.